this assessment, we're going to calculate KEQ for the hypothetical equilibrium shown. Essentially, it's the conversion of a trans disubstituted alkene into a trisubstituted alkene. We expect this reaction to have a KEQ greater than 1 because we know that the trisubstituted alkene is more stable than the trans disubstituted. Always make a guess before we start plugging numbers in, and we'll see if we get a value greater than 1 as we solve the problem. Here are the equations that we're going to use to solve the problem. We're going to start by recognizing that in this case we're going from one molecule to one molecule, so we don't have to worry about entropy, that delta G is going to be equal to delta H. And that's good news because we have this table here that gives us kind of a number that represents the stability of alkenes. Note that it gives the negative of a delta H of hydrogenation. So delta H of hydrogenation is a negative number. This table shows the negative of that number, and so we're going to have positive values. But the more positive the value is, the less stable the alkene is. And so we see that when we look for the number for trisubstituted, that value is going to be 26.9 kilocalories per mole. And I've run a little bit out of space, sorry about that. The trans disubstituted alkene is going to be 27.6, so a slightly higher number for a slightly less stable alkene, exactly what we would expect. If we take 26.9 minus 27.6, that's going to give us the delta H, which is going to be equal to negative 0.7 kilocalories per mole. That's exactly what we would have expected as we go from trans disubstituted to trisubstituted. When we plug this number in up here, we can now calculate KEQ. I'll try and be cognizant of space here. Negative 0.7, all of that over 0.001987 times 298 Kelvin. Do that calculation, we get a KEQ that is 3.26. It is in fact greater than 1. The right side of the reaction is favored, just as we expected, based on the stability of the trisubstituted alkene being greater than that of the trans disubstituted alkene.